with Josh Patterson. What's up, Josh?
Hey, how's it going? Thank you for having me.
Such a pleasure. And Josh is the co-founder and CEO of Voltron Data, a company on a mission to accelerate standardized data processing and enable faster, more efficient analytics and AI workflows. And I know this is something we're all constantly craving. We're here today to discuss the future of data processing, how it will impact all of us, data scientists, MLEs, data leaders, everyone involved in the growing AI space now. I would love for you all to, oh, just one second. Yeah. I would love for you all to introduce yourself in the chat. Let us know where you're calling in from, what your interest in such things are. I'm actually in Sydney, Australia, so it's Friday afternoon. We just passed high noon. Josh, you're in South Carolina?
Correct, Charleston, South Carolina.
Well, thank you so much. As we both know, I very much appreciate you joining after dinner at 10 p.m. local time. So that's super
Thank you.
cool. Once again, please do introduce yourself in the chat. And this is a fireside chat hosted by Out of Bounds, where we're working on infrastructure and productivity tools for data scientists to essentially allow data scientists and MLEs to focus on building models and doing data science while having easy access to all the infrastructural layers, such as compute, orchestration, versioning. We do a lot of this through the open source Metaflow, which my colleagues built and open sourced at Netflix, but we're working on Out of Bounds platform as well. So check that out. I'm actually going to put a link to the open source Metaflow in the chat in YouTube. So check it out and give it a star if you're interested in such things. I'm also going to put a link to our next fireside chat, which is next month, it's with Josh's wonderful colleague Chip Huen, which is going to be about ML engineering and the shift from ML engineering to AI engineering. So that's going to be super fun. And it was actually Chip who introduced us to do this as well, Josh. So
That's amazing.
congratulations on working with her as well to all of you.
Thank you. It's honestly been a dream of mine for a while. I've known Chip since my Nvidia days, and just super excited she's on board with Voltron Data. So thank you, Chip, again.
Absolutely. And look, we've got people tuning in from New Zealand, from several places in Australia, California. So we've got some nice representation all around the time zones. So Josh, you have a fascinating background as director of engineering at Nvidia, director of data science at Accenture, co-founding Rapids, open source project for GPU accelerated data science and machine learning, which I really hope we get to. Someone's tuning in from North Carolina, so not too
Woo-hoo!
not too far. Someone in Seattle. Hey Nicole, great. And then I'm putting kind of the cart before the horse slightly here. Then to build Voltron from like your Rapids background, you partnered with the blazing SQL people and Wes McKinney to build. Funnily, this is a total coincidence. I don't know if I've shown you my new notebook. Oh, can you? This
No,
is
I can't
actually.
see it.
Oh no. Oh, it's okay. That's a real shame because I'm actually. I'll turn my background off to do this. This is slightly
Oh, I see it
embarrassing.
now.
Oh yeah,
Transformers.
exactly.
Yeah.
So it's there there we go. That's what it feels like in many ways. So that's all to set the scene. I'd love just to find out a bit more about your background and your journey from Nvidia and Accenture to founding Voltron Data, and what made you spend so much time doing this? What attracts you to this type of work?
Yeah, man, that's actually a great question. It really started at Accenture. We were in a cyber lab. Prior to that, I was at Accenture's big data lab. So Accenture, at the time it was like 300,000 global. They're way larger than that now. But they were 300 of us in labs, and there were labs across the world, Tel Aviv, DC, San Francisco. There's one in Sofia, France. Just all these really cool places doing really cool technological innovation. And I just left the big data lab and was coming back east to get married. And I joined the cyber lab to do threat detection, threat hunting, essentially, you know, cybersecurity plus big data. And at the time, kind of machine learning. The world was kind of just dabbling in integrating graph and machine learning. And really, for a long story short, we were trying to do better threat detection, and we realized that graph analytics, structural properties, plus time series data, plus machine learning, was doing really, really great threat detection. And so just kind of taking the tabular properties of data, the graph structural properties, time series properties, putting them into one corpus, and we could, really find threats faster, better, uh, quicker. And graph analytics is really, really slow. At the time, we had Giraffe and GraphX, and doing things like PageRanker in between a centrality was just extremely slow. And we were working with Georgia Tech, and Professor Bader at the time was like, "Hey, have you looked at GPUs?" And we stumbled across this group called Blaze Graph. They eventually got acquired by AWS, and they're the folks behind Neptune.
Mm.
But long story short, we had an 80 node cluster that was doing PageRank for the data set that we had in about 30 minutes. We could do it in BlazeGraph on 8 GPUs in about like 20 to 30 seconds. In fact, it was so fast, we just thought it was wrong.
Yeah, yeah.
We're like, it aired out. Like, this can't be it. And then, we started doing like, checks. And we're like, wow, this is fast. This is like really fast. And then we were hooked. And so if we knew that the cost of doing cyber defense was way too large, how might we do it faster and cheaper? And the first cornerstone of that was, using GPUs for graph analytics. But we couldn't pump data into the systems fast enough for that. And we realized there was a lot of communication problems, communication overhead of moving data from CPU systems to GPU systems. And so we had two core thoughts. One was GPU accelerate more things, and two was we needed better ways of data movement. And so that was right at the time Westlake kind of kicked off Arrow. And so in 2015, we were just laser focused on hardware acceleration. Wes was off building Arrow, and we're like, okay, whatever we do, it should be Arrow centric because if we're having this problem crossing language boundaries, it's even worse when you cross hardware boundaries. And so I joined Nvidia after basically spending 18 months on the black hat strata talk circuit, being like GPUs are the future. So Nvidia kind of got wind of us, and they're like, "All right, this is kind of cool. Let's bring that whole team over." Um, and we were inside, and we were like, we knew Nvidia had to have some like really cool secret sauce for data analytics. But largely they were laser focused on HPC graphics. Deep learning was just starting to emerge at the time. The company was really starting to like latch onto deep learning and really kind of pump resources
Mm.
behind it. And we were kind of just this like kind of dark horse where we were like, but GPUs are good at analytics too.
And wait, is this around 7, 8 years ago or something like that? Or am I?
2017, late
Yeah,
2016,
yeah. Okay.
early 2017. So I joined probably like November of 2016. And so, early 2017, we're really pushing this like idea of GPUs for analytics. And everyone's like, I mean, deep learning is kind of the thing. What are you doing? And I'm like, you gotta feed these systems. Like eventually deep learning systems are gonna get so fast, like we have to accelerate analytics. I just kept like saying it. And eventually, I had a meeting with Jensen. And it wasn't the best meeting of my life, but it just really shows kind of the genius of Jensen. He really dug in. It was like, tell me more about this, tell me more about that. What is this, thing? Why is this Spark thing over here doing this? Explain this whole Scala, Java, JVM. Why are they problems? Um, and one really, really tough meeting, he ended it with, "Hey, this was really good. Like, let's go back and do it again in a few weeks." And every couple of weeks, I would go back to his office and talk more data analytics with him and kind of whiteboard the ecosystem. And those were the early days of Rapids, and kind of like what we whiteboarded early on is was the design plan for Rapids. Let's do what we did for deep learning. How Cudian is deep learning is how Rapids was meant to be for other frameworks. We built the low level computational kernels, and the goal was to have all the functionality GPU accelerated, um, and then expose that to higher level systems, DAS, Spark, what have you. And when we started this, I was like, Jensen, it has to be Arrow native, because if we can get data from system memory to GPU memory without a copy and convert, we've really reduced the boundary. And with, NVLink going where, it was going, and with GPU direct storage and GPU direct, for GPU to GPU communication, the more that we built Arrow native, the more we could kind of like break some of these boundaries. And so um, we just went off to work, building, essentially everything for the GPU: decompression, compression, um, readers for CSV, Avro, org, JSON, just all these things, all the compute kernels for, sorting, building hash tables, probing, ML algorithms. Um, and then we launched it in 2018, and kind of the rest was history. Um, and from there, we just wanted to keep making it easier and easier and faster and faster. And by the end of 2020, I think we just hit this wall where we didn't really think that existing systems were designed for accelerated computing.
Mm.
Um, so we had been working with Blazing SQL for years, and what we realized is you had to design up for GPUs for accelerated computing. Um, and we kind of just had this crazy idea to just like bundle all this together in one big company. What the Ursa Labs folks were doing around Arrow, what Blazing SQL was doing around accelerated systems. Uh, we brought on a lot of hardware engineers. There was this group doing FPGA Arrow work out of the Netherlands, and we just really brought it all together. And we're like, how could we build better systems that were just built from the ground up to be cloud native and accelerated native, really taking advantage of open standards and everything else. And it was just a goal to keep pushing the bounds, making these large scale data systems faster, more efficient, um, and easier to use. And I think ease of use was just a massive North Star that others kind of missed in the past.
Yeah, absolutely. So I'm wondering if you could give us an overview of kind of the ecosystem of open source projects and tools, because there is a lot to, and I'm almost for data scientists and machine learning engineers, I'm wondering if you could almost like Eli 5 explain it like we're five to us, in terms of like the value. Why would I use an Arrow? What is the value prop of Arrow? Similarly for Rapids and Blazing SQL, kind of what all these tools do would be super useful, and how you think about them.
Yeah. So first plug is, if you have to think about some of these open standard tools, we've done something wrong. And so, my daughter, one of her favorite books, she's 4, is this book on physics. And I know it's kind of like who reads their kids' physics books? But it's this like cute 4-year-old version of physics,
Yeah,
and it's like
amazing.
Newtonian physics, things have mass, gravity, apples fall from the tree and hit Sir Isaac Newton on the head. Um, and that's kind of how I think about open standards. They're like gravity, like you shouldn't see them, you shouldn't think about them, but they should be there, and they kind of support us to,
Yeah.
well, live. And so at the highest level, data scientists, they shouldn't think about open standards. They really should be pervasive through the libraries that they use. Um, but how we think about Arrow and a lot of the other tools that we build are like Lego blocks. Everything should just stack on top of each other to allow people to build these really, really great things. We don't want like, big Lego blocks and tiny Lego blocks. And, you want the whole ecosystem just kind of snap together on top of each
Mm.
other and to build upon each other. And so, when you're playing with Legos and you're building something, you want the base to snap on tight so you can build things on top of it. And that's really how we think about open standards. And so Arrow, at its core, is just one of these Lego pieces, but you can move it from system to system, and it just works. Even if you're playing with, the yellow Lego blocks or the green Lego blocks or the blue Lego blocks, and each color could be a language or a hardware. I should be able to move these Legos from, system to system and kind of compose something together. And so it's just a standard way of thinking about what is a Lego block.
Mm.
And so that's what Arrow is to data. It's just a block of data, and it's built in a modular and composable way. It's a columnar format. So instead of row based, it's column based, but it's meant to be a standard. And so whether it's Rust or Go or Python or Java or C++. Arrow is Arrow. How it lays out data is the same. And so it just can, different systems can pick up the Lego block and it's like, I know what to do with this.
Mm.
Um, and so that's, really the cornerstone of all the systems that we've been building since, 2016 has been Arrow. Um, there's some other projects that we've been really kind of passionate about. IBIS is one, Substrate is another. And so what Arrow is to data and data layouts, Substrate is to relational algebra or like your data frame logic. Like, what do I want to do with data? So, like, how do I, represent a join? How do I represent a group by? How do I represent these functions? And you're like, well, all these systems have these things, but all the systems have different way of calling these things, whether it's SQL, whether it's, a data frame API, whether it's Java. And so underneath that, there's this logical thing that is an operator, is this relational algebra, is like what I want to do with data. And so that's what Substrate is. It's like, how do we represent this, kind of cross-language, cross-system way of, representing what kind of a data operation is. And so if we standardize data and we standardize data operations, we get this really magical effect. We can start to decouple, you know, data lakes and data movement from data engines. We can also start to decouple APIs from engines. And so, where we're really trying to go with this is I should be able to write something in one language or, one system's API, but send that instruction set to another engine. And that engine should be able to read data and pull data from other systems very graciously. And so now we can have really, really cool things like the R language talking to DuckDB or a Java API talking to a GPU C++ engine. And now we can start to stack, again, these Legos together seamlessly. So I can stack APIs on top of engines, on top of different data lakes, and it all just works seamlessly because of open standards. And we're already seeing this kind of in our data lakes with Iceberg and Hootie and Delta. They're all starting to get standardized across things like Xtable and the Unity catalog. And so you're getting this really awesome standardization, but under the hood, they're Parquet and Arrow. They're standardizing their APIs. And so now you can have data lakes stack on the engine you want and eventually stack on the API you want. And now you have like a system. And that's really powerful, from going from the world of this system had their own API, their own engine, their own data formats, to this composable world. It accelerates innovation. It's just really exciting.
I love it. And I've always, the more composability in general and the more Unix-like philosophies we bring to data, ML, and AI, I'm incredibly excited about. I This brings up a lot for me. It was years ago, maybe 2016 or 2017. I was at the inaugural JupyterCon in New York, and there were so many great speakers. But I remember there were four speech talks I really loved, and I think Wes was one of them, talking about Arrow. And Hadley Wickham may have even been there with him to talk about Arrow together or something like that. But there were two other talks by Fernando Perez of IPython and Jupyter fame, and Peter Wang from then Continuum, now Anaconda. And Peter gave a great talk about Python as a substrate for innovation. And Fernando gave an incredible talk around, there are to build things, we need to agree on some things first, right? And the fact that, he still gets issues raised and pull requests of stuff which challenges the very foundation of how IPython works. And he's like, we've agreed on, this particular thing. And I think that's a really important thing here, because I want to know the types of challenges you've faced in thinking about these open standards. And I presume one is these first levels of agreement on what they should look like. So maybe you could use that as a launching pad to tell us a bit about, I suppose, some of the key challenges you've had in standardizing data processing across different platforms and frameworks.
Yeah, I mean, one example is one that, we still kind of are working with today, is even within Substrate, is at what level is Substrate really meant for? Is it meant from this logical level, from API to engine, or is it meant from like API um, to compute kernels? And so when you think about an engine, you're starting to see a lot of these really amazing things in the Spark world, where you have like the Comet project and Gluten, where it's taking the Spark logical plan using Calcite to still do its optimization. And then you get all these physical plans. But instead of using Spark to execute the physical plans, they're plugging in these like columnar vectorized engines. So these
Mm,
arrow-based engines like Data Fusion or Velox to accelerate Spark, to make Spark faster. And so there, people are like, well, I could probably use Substrate from this physical plan mapping to this columnar vectorized compute engine, and Substrate will be this kind of layer there. Where others are thinking about Substrate a layer higher, with things like Spark Connect, I can, send a Spark instruction set, but instead of sending it to a Spark cluster, I might want to, use Substrate to send it somewhere else. And
mm,
so it's really kind of this logical plan interception. And, they're very different, but they're still within the same project. And so that's just, one example where, we have to kind of agree on, what's the priority, what's the direction. And you see this in Arrow a lot, different languages kind of move at different paces. Arrow, Rust, had data fusion in it, and then data fusion spun out as a like top level project. And so you don't want to stifle innovation, but then also you want to kind of specialize in the things that like well and that move forward other things within an ecosystem. And so open source is really a balancing act. You have to uh, constantly pour in and kind of steward these relationships and think about kind of what's the greater good. And every now and then you'll still get these kind of like spin up projects that are trying to do things that other people have already done.
mm.
There's no shortage of like, hey, here's a new Python data frame API. But we believe in IBIS. We think IBIS is great, and so we're kind of like, hey, look, these other APIs, they're cool, but IBIS has 22 backends. It's used by local engines, GPU engines, um, batch engines, batch distributed engines, now even streaming engines like Blink and Rising Wave. So it's like, yeah, some of these other things are great, but IBIS is, mature and, doing well. And hey, if there's some limitations of IBIS, let's fix those. If there's something about, this packaging of it or this or that, just instead of, starting a whole new project because you don't like this one functionality, maybe just open up a feature request or an issue and like, let's talk about it. And so a lot of this is, when you build standards, you have to constantly engage the community, and, really just kind of be a little bit empathetic about like, hey, what's your problem? How can we, use what's here today, versus kind of reinventing the wheel. And early on at Rapids, that was kind of our core theme. We didn't want to reinvent anything in the ecosystem and really just leverage everything else to just focus on what we were really good at, which was GPU acceleration. And that's why we built on Arrow. We mimicked the scikit-learn API. There were just so many things where we're like, hey, these people are leading kind of pioneers. By the way, I want to plug your scikit-learn hoodie.
Oh yeah.
Uh,
Thank you. We got to get you on soon as well.
Absolutely. And so we just really wanted to like stand on the shoulders of giants and just like, build things in a way that people were used to and, also just not reinvent the wheel on things that didn't need to be reinvented.
Makes sense. Um, we have several interesting questions in the chat. I'm going to ask one from Roshan, and I just want to remind people who are here that feel free to ask questions in the YouTube chat, and we'll try to get to them. Roshan has an interesting question around. Roshan asks, could you provide some examples of file format bottlenecks, which are big problems and low hanging fruit that your tools can solve or optimize? So really speaking to the end user data scientist experience.
Um, so that's a great question. Parquet, I think, is becoming, the de facto standard for, data at rest. And I will juxtapose that with CSV, this data format that will never go away, no matter how much people want. I still talk to customers today where they're like, we generate, 80 terabytes of CSV files. And I'm like, 80 terabytes
You should not be
a
doing
day?
that.
You should not be doing that,
Yeah.
but it still happens. They're like, we still need systems that can read both Parquet and CSV.
I just want to say,
And
I do understand that. I think I told you beforehand, I lived in Germany for some years. I worked in an office that still used a fax machine about 7 years ago. So, this type of antiquated technology happens in all facets.
and so when we were building, GPU readers, it was one of those things where it's like it has to be robust. It has
Mm.
to deal with, all the intricacies of reading a CSV, as well as be able to read Parquet extremely fast. Um, and through that process, we actually realized that for all the things that Parquet is great at, is actually not the most optimized format for accelerators for GPUs. You have some very limiting factors of Parquet with how it's compressed and how it's laid out. And there's actually this working group with Meta and a lot of kind of leading academic researchers out of CMU and other kind of top tier universities. There's some Voltron data people there, other open source people there, really looking at file formats and kind of the future file formats. I think Wes and Andy Pavlo and oh man, Pedro, out of the Velox team, they wrote a paper about it recently. And there's a lot of optimization left in making even file formats faster, more compressible, I guess is the word I'm looking for. Maybe not. Um, I apologize to everyone. It is 10:30 on the East Coast.
Not at
So
all.
my brain is just fried at this point.
You're doing great.
But Parquet still isn't, the end of the road. Like,
Hmm.
you know, I look forward, probably in the next couple of years, the emergence of a new file format that's, uh, that can, be represented on disk in an even smaller footprint that's even better at, being read by GPUs. And we can get some really, really impressive read times. And so like reading Parquet, I think a beefy, like 60 plus core CPU can maybe get up to, 500 megabytes per second. On GPUs, per GPU, we can do, 10, if not, 20 gigabytes per second of reading Parquet. And that's fast, but with GPU direct storage and 200 gig, 400 gig, InfiniBand and Rocky, we can actually push even more throughput. And so we really need to keep pushing the bounds of reading and writing, compression, decompression, and all these things. And so where file formats are today is not the end all be all. But I will say, things like Rapids and DuckDB and Data Fusion, they're extremely, extremely good at reading,
Yep.
Parquet, significantly faster than like even 5 years ago, the tools and technology. And so these modern, libraries are just getting faster and faster kind of every generation. And so I'm excited for the single node kind of developer um, experience. You can just do a lot more with these kind of really big core, big memory machines. And I'm also, really excited about distributed systems. Distributed systems are getting more efficient and faster. And just, I'd be remiss not to plug Theseus, just kind of
Mm.
using a bunch of GPUs to read data, into memory, doing analytics on it, even out of core, just really pushing the bounds of what you can do now. But the better thing about this is developers shouldn't have to think about this.
Yep.
Data scientists, data engineers, again, if you're thinking about how do I read Parquet fast, somebody in the Lego block ecosystem has like messed up. We should be able to just write SQL, write Python code, and then target different engines, and all those engines should be able to read data at rest extremely well now. And
Mm.
I think that's kind of, again, this whole IBIS to data engines to Parquet or Arrow, it is what's so empowering. Like people should not be thinking about like what is my format. outside of please use,
Yeah,
Parquet or Orc or something nicer than
absolutely.
CSV.
We have a few questions around the burgeoning AI space, and some of them are specific. But I want to ask it just a more general question to start off with the rise of LLMs and generative AI. I'm just wondering if and how the landscape for data processing and computation has changed. So maybe you can speak to the new challenges or opportunities that have emerged in managing and processing data for these systems in the past handful of years.
I think, there's a lot of ways that we can think about how, large language models, LLMs, are affecting data analytics. And there's three ways. One is using LLMs to write queries, using LLMs, within a query,
Mm-hmm.
um, and then using LLMs in place of a query.
Mm-hmm.
Um, the last one I'm just going to kind of ignore for the moment and really kind of focus on the first two. Uh, in the past, to do some type of like, um, what is the sentiment of this? Is this a negative review? Is it a positive review? That was a lot of work. Um, you would have to have a corpus, you would have to, do certain things with data. You would have to train models, do this whole, kind of split your data set, sample your data, train a model, test it on your out of sample data, iterate. Um, and it's actually just wildly amazing that you can, take an LLM and just kind of ask it a question about a set of data, and it gives you a pretty highly accurate response, probably better than
And ask
most
it
of
in
the
natural language, not in SQL or some, bespoke DSL or
right.
that's
And
wild.
it's really wild. And I would go back to my early 2013 Accenture days when I was, doing sentiment analysis for a customer, and I'm pretty sure LLMs out of the box, are wildly better than models that would take me weeks to train. Um, Wildly better. And
Maybe
so
they've
that's
even
just
been trained on those models. No, I'm kidding.
maybe. And so I think that's just, just really cool. And so, uh, a query and a query is kind of how we talk about it. First, I need to query, some other table, join some data around, and then I want to, have this other like query or prompt inside of a query, and being able to chain these things together, that's really exciting. And so now you're kind of making data analytics even more powerful because it's like the amount of work you would have to do to say, hey, for every product uh, in my data set that is a luxury good. I want to find the ones with negative reviews, and I want to know, the revenue for the last 3 months for those products. That was a month-long project
Mm.
that now is just chaining SQL and LLMs together. So, hey, that's just exciting and changes a lot of things. The other side is I can ask something in natural language and produce a complex query. It's really empowering people who aren't data engineers, data scientists to write code faster. And I think now more and more people are actually experiencing, oh my God, this is slow. This
Mm.
is this is painful. And so, speed is coming back into to in a style. Mentioning Peter, when we were launching Rapids, he's like, I was just so excited for people to, bring speed and performance back to data science and data
Yeah.
analytics. He's like, too long do we kind of like forget about performance? And just like, oh, we'll just throw more hardware at it and we'll just scale this kind of map reduce thing out. And he's like, you all are gonna kind of make, performance cool again. Um, and the further we've kind of pushed into AI, the more and more people push performance because you have this weird thing, that's every 6 months, these NVIDIA GPUs are getting bigger, faster, their software is getting better. And so AI is getting faster and faster and faster. And so it forces everything in that data pipeline to either get faster or you have to scale out even more. And so you're feeling this pain, this like wall of like if we don't make this other stuff faster, this AI stuff is going to get so fast that it's like you're not going to be able to keep up with it. And now that we can start generating queries and all these other things, people's imagination is only limited by the speed of their systems. And Francois Chollet, we met at AnacondaCon a few years ago, and first off, if you ever have to do like a keynote after him, you might as well just not
No,
do it. He's a brilliant
brutal.
speaker.
Yeah.
It was it was really tough going after him. But he had this really great talk about, you know, elite data scientists are no different than, everyday data scientists, except they're just better at iteration. And so if you could take any data scientist and allow them to ideate, test, and evaluate faster, they would be elite data scientists too. And it was almost this like, don't feel bad. You just don't iterate as fast. You don't have the tools to iterate as fast as other data scientists. And like the difference between like the Kaggle Grandmaster and like, you know, a new data scientist, yeah, they might have some other new ideas and they might be, better at like, oh, I've seen this before, so I'm going to start here. But if we could iterate faster, this like
Mm.
full loop of
Yep.
like thought, test, train, evaluate, if we could just speed that loop up, uh, you would just be a better data scientist. And so, that's kind of the the forcing function of AI. AI is allowing us to innovate and think faster. Well, now we need to be able to like evaluate and test faster too. And so it's forcing the full system to start thinking about performance again because, with large language models, it really is kind of like this co-pilot effect. It's helping everyone think faster and iterate faster, and so
Yep.
we have to like, keep up with that. And so I'm excited. I just love. I'm a performance junkie, and so forcing this world to really kind of think about performance and compute efficiency, I think it's just really exciting, and I look forward to kind of uh, the caliber of data science in the next couple of years that everyone just keeps elevating, how they do things, with this, the assistance of large language models.
Awesome. I love the idea of kind of the AI, everything that's happening in the generative AI space being like a strong forcing function to make all of this work even faster and performant. Particularly, I'm happy for you as a performance junkie that you get this forcing function as well. So we've talked about the implications of what happens in data processing given all this AI stuff. There's a question that I'm going to slightly rephrase from Tam Nguyen. I think Tam is interested in whether you can use AI to help you build such tools and to work in data analytics. So as opposed to hardcore data processing for AI to help you do what you do.
Uh, a significant number of our engineers are using some type of like Copilot or generative AI assistance today. If it's using AI for generating unit tests, documentation, hey, how might I write this function? Um, Especially on the testing side. Hey, I want to generate a bunch of tests to validate that this function is doing what it's supposed to do. Um, it really is accelerating development, and just kind of software development in general. If you're not using some form of AI to kind of assist development, um, probably not developing at the speed in which you could be. And even some of our, more, senior, hey, I'm really good. I've been, building software for a while. They kind of started playing around with Copilot and other, generative AI tools, and they're like, wow, this really does like
Incredible.
accelerate my productivity in a very different way. It makes mundane things not mundane. Um, yeah, it's 100% accelerating software development.
There are several parts of it for me. One is just the way it helps with boilerplate. The other thing that I really love is how I can paste in like local error messages and stuff that Google wouldn't respond to because it has all of my own file paths and stuff like that. But it just abstracts away all that stuff and gets to the root cause immediately as well.
Absolutely.
Um, I wasn't necessarily thinking of going here, but you mentioned Rust. I am, we've been talking about a lot of cross-platform tools, but you and I think and work a lot in Python as well. So And finally, the last Fireside chat we had, and I'll put a link to this in the chat, was with Wolf Volprecht, who he built Mamba,
Yeah,
part of the Condor ecosystem. He's working on Pixie and a variety of other things with his company Prefix now. But speaking about, I mean, we're talking about speed and performance, man. Like the stuff he's doing with package management and dev environments and containerization with respect to performance is pretty out there. But he's doing everything in Rust these days. So, I mean, we didn't prep this part of the conversation so much, but I'm just wondering any thoughts on Rust and Mojo, right? Like there are a whole bunch of different tools in the space, and of course, Chris Latner is someone. Whenever he does something, it's probably worth watching and taking somewhat seriously, right? Um,
absolutely.
so yeah, I'm just wondering, like, how you think about these exciting developments in the space as well.
First off, huge plug for Modular. I wish those people the best. Amazing team. Just super excited for Chris. Um, performance is performance, begets more performance essentially. And so as people start to go down this rabbit hole, you unlock things and it, forces you to kind of like fix other lower level things, unlock even more performance.
Mm.
Um, and it also forces interoperability. Once you kind of get this fast at something, you don't want to like let it go because of the next tool in the chain. And so, the Arrow Rust community really kind of pushed on performance, but it also allowed kind of Arrow to get better. Hey, here's a better way that we were doing this in Rust. You should adopt this in Arrow C++ and Arrow Go. And you saw this like cross ecosystem adoption of performance because different parts of the community were really, really, really focused on performance. Um, and so even like when we were building out Theseus, we were thinking about like how might we allow people to have UDFs, user-defined functions,
Mm.
across different languages and other things. And so Theseus is a C++ engine mainly because CUDA, NVIDIA GPUs, you use C++ to interface with them. There is no like really kind of standardized production ready way of talking to a GPU with Rust. But even with that said, even with it being a GPU engine, we still might want to call out to, other libraries that can run on GPUs like, Mojo or Triton out of OpenAI, or somebody might have some Rust code. And Microsoft had a really great paper about how, with Aeroflight, there was actually a very small penalty of actually sending a chunk of data to a whole remote server, doing processing and sending it back. And so you could think about like a compute engine running, you could have a distributed compute engine running, somewhere. And then when it hits a user-defined function that might be written in a different, language, instead of trying to do some kind of fancy way of doing some type of, foreign function interface, you could actually just send that UDF to a serverless environment, run it, and then send the result back. And as long as it's arrow in and arrow out, the penalty for running it like off server is like negligible, like 10% performance. And so it was a really cool paper out of Microsoft Research. And so we really took that kind of concept to heart. And so like when we're building Theseus, everything is connected through Arrow to Arrow Flight. And so if there are these things that we want to run that are Rust or some other language, we can. Um, and again, the core thought here is Lego blocks. We can stack these things together, but also we can, extend things like very, very graciously. So when people are doing really fast things, as long as we can send them data quickly, we can return result sets back to us really, really quickly.
Mm.
And so it also prevents like rewriting the wheel and reinventing things. I think data engineers spend way too much time. Oh, we have a developer. They developed this whole code over here, but we want to move it in production, but it can't be slow. So we're going to rewrite all of this code. Now with Arrow and being able to basically, kind of just send, chunks of data through Arrow Flight. If there's a part of the logic like really dense, but it's already performant, maybe you don't rewrite it. Maybe you just have this kind of like serverless layer that just you send, data to it through Arrow Flight, it returns something back, and then you can continue your chain of process. And I'm starting to, see a lot of, customers. There's an FS customer that I talked with today, and they're like, yeah, we essentially like daisy chain systems together with Aeroflight. And so people can like write this performant code in the languages that they want. And we use Arrow as a way to like pass data through these systems more graciously. And that was just like, man, that's awesome. Um, so yeah.
Amazing. I we've mentioned I love the Lego analogy. We've mentioned composability in a variety of ways. I just posted a link to another Fireside chat we did a few months ago with Simon Willison, and it's very relevant because we actually called it the Zen of Python, Unix, and LLMs, and it is all about composability in the generative AI space. So Josh, there are a couple of things I want to bring together. You've mentioned that if data scientists are thinking a lot about open standards, that someone else hasn't done their job. You also mentioned CUDA. When do data scientists get to never have to think about CUDA kernel errors again?
Uh, wow, you just really went for the jugular with that question. Um, you know, probably around the same time, they're never gonna have to think about what is this random like JVM error in
Yeah.
PySpark. Probably not anytime soon.
Yeah.
It is the real answer. Um, but I actually think there's like hope at the end of the tunnel with, as you said, people being able to take an error message and, just basically like send it, like ask some, generative AI system, like, what does this mean? What's happening? I
Mm,
think you're soon going to start having like AI in the loop. You get an error message and it's like, here's
amazing.
why you got this error message. Rewrite this query this way. Or, this data set has this column malformed or blah, 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 or whatever the error is. And it's basically like, if we remove this, would you want me to rerun this?
Right.
And so I don't think we're terribly far away. There's always going to be error messages,
And
but I think,
I was only half joking as well. And it is a wicked problem to solve as well.
yeah. But over time, I do think these error messages are, um, I don't want to overhype this idea of like self-healing systems. Um, but I do think we're getting closer to these like, hey, here's the problem. Would you want to retry this? And I think we're getting incrementally better, also in system design with, kind of this correlation of like error messages to root cause problems, and then like surfacing them up in a way
Yep.
where people can like self-service a lot better.
Yeah.
Um,
And you can stay in the zone or in a flow state as well without, banging your head against the wall figuratively or literally so much. You mentioned
Absolutely.
Francois Chollet, who, if people who are watching don't know him, I mean, he's done many things, but he created and works on Keras. And I still remember it must have been 8 years ago or something when I first used Keras. I didn't know you could have error messaging which could be that useful to me as a developer. I was like, this is actually amazing. It's like this, you had this error, then it was like, maybe you should try this instead. And I was like, thank you.
We were inspired by him in Rapids.
Yeah.
And again, that talk that he gave right before mine about iteration speed. He also had something about like error messaging and standardization of like, across systems. And he was talking about deep learning systems at the time, PyTorch, TensorFlow, Theano, MXNet. Like having variables and APIs that use the same arguments was really important because like minor changes cut down on your iteration speed of like testing new ideas. And sometimes you might just have to use like TensorFlow because of a certain functionality it has, and you want to test an idea, but then you like constantly get tripped over by like malformed code because you're using like a PyTorch syntax. Um, and there's actually no reason why they're different. And he's like,
Yeah.
why are these things different? And so, I can't think of the example he gave, but it was something around like Axis. And he's just like, it should be the exact same from scikit-learn through all these libraries because it's
It's
essentially
the same.
in an argument, on, a certain specification of a vector. And like, we should be just, using the same lexicon because every time we change this, it just trips up developers and it slows down their speed of innovation, which slows down their experimentation, which like makes them a worse data scientist when it's really like we as systems and library developers are like doing this for no reason. And so this is why I always say that like, APIs in the past were a moat, but I don't largely believe that APIs are a moat anymore.
Mm.
And huge plug to the guys at Tobacco. Huge fan of SQL Mesh
Yep.
and SQL Glot and all the other cool stuff that they're doing. Um, I don't think API should be a moat. And people are like, be like, oh, this API, with Substrate and all these other open standards, eventually APIs we'll be able to point APIs, to almost any engine. And especially with kind of this rise of there's a startup that's using IBIS and LLMs to like essentially basically transpile code. I can't remember the name of it, but they had a cool article I read a few weeks ago. I think that the moat of APIs is breaking down. And so if
Yeah.
that's true, people should just start to standardize today on things that like really don't have a consequence to their system because it just makes it better for everyone else.
Absolutely. And I love you mentioned the example that Francois gave of all these machine learning packages, and that they should be doing the same thing as essentially. It actually reminds me the talker that I'm pretty sure it was Wes McKinney giving about Arrow the first time I heard about Arrow. I think he gave the example of what actually happens on your hardware when you do a group by in Pandas and then when you do a group by in dplyr. And he's like, why are these such different things? They shouldn't be at all. And that was a kind of one of those aha moments for me, recognizing it across all the tools that we use completely.
Well, I think Velox takes it even a step further. Why are we even recoding how to do like to build a hash table
Yeah, yeah.
and then they're like, at Meta they have all these different data systems, but ultimately they're all doing like the same sets of operations. So what if we had this one columnar engine that was vectorized that we could plug into all these systems?
Mm,
We could use work once and like basically get the advantage of it 12 times.
yep.
And that was uh it was refreshing because that was the exact same thought we had for Rapids. What if we built these kernels one time really well? Um, we could just plug it in all these other systems. So whether that was Rapid, sorry, whether it was Dask or Spark or Blazing SQL, now Theseus. We've always encouraged many people to use it. Databricks recently announced a couple weeks ago that they were going to add GPU support to Photon, and you're
Mm,
like, right on, because they're going to probably stumble across some corner case with some kernel and be like, hey, let's fix it. And so it's going to benefit all the other users of those Rapids libraries.
amazing.
And so I mean, hardcore believer in open standards, just making the whole ecosystem better.
Yeah, great. Gonna have to wrap up soon. We've got some really interesting questions in the chat, and somebody whose handle is glory to God just wrote fascinating exclamation point. So, wild stuff for a Friday. Someone's actually asked, they want to know what keeps you up at night, and some other people have plus one that question. So yeah, what's the thing that itch really? What's the itch you got, man?
Um, I'm a huge cybersecurity fan. And without throwing shade at anyone, I don't think our defense systems are nearly as good as how attackers and malicious actors are using AI these days. And that's frightening. Um,
And
I
I just
think
want to
that
say that there's no as far like I chat with some people about it, but in terms of cultural consciousness, there's negligible conversation about security concerns with machine learning and generative AI today.
it's absolutely frightening. And so, I have young kids, and you're always like, man, what kind of world are they going to grow up in? Where like, you know, uh, AI is just moving, kind of so fast, and kind of like, how do you guard, things? Um, and it kind of is also the thing that like drives me. It's like why like we at Voltron Data, actually I take a step back. At Voltron Data, a lot of people are joined in there for different reasons. And it could be open standards, open source, you know, they're HPC people who just love making systems fast.
Mm,
Um, but for me, part of this whole thing of composability, modularity, interoperability, extensibility, acceleration, all of it, it really was born out of a cybersecurity problem. It was these systems are way too clunky, way too slow, way too expensive, way too brittle to really do threat detection and kind of advanced persistent threat hunting fast enough, cheap enough. And so I've always wanted to you know, make this space better, and this space being like the cyber security, incident response, threat detection space. And so I took the longest, most roundabout journey into data systems to do it. Um, but no, every now and then when you read about a breach here or a breach there, it's kind of like, man, these are some really, really top tier companies with great systems, great engineers, great security teams, and they're still getting breached. It's just like it's kind of the Wild West right now, all
absolutely.
over again. And so that's probably the one thing that kind of wakes me up sometimes in a panic. Um, but honestly, besides that, I have two young kids, and so they run around all day so much. I pass out a lot of nights, and I'm very kind of thankful for them.
Yeah, for
Yeah,
sure.
they allow me to sleep. So,
Awesome. Um, Look, Lawrence has got a good question, which is actually out of scope, but I do want to mention it. Lawrence says, what about the AI industry itself being a bad actor in grabbing any and all data? What is ethical data acquisition? I will say that's out of scope. I do want to say the AI industry is a huge, sprawling space. There are bad actors, of course. There are very good ethical actors who are trying to think in principled ways about all of this. I mean, you can look at certain LLM providers who are actually trying to license things now because they
absolutely.
recognize that regulation is coming, but also for ethical reasons. Also, just to be clear, like the AI industry, some of it is grabbing any and all data. Sure, this type of stuff predated AI. Like, it isn't like tech companies pre-AI weren't, let's say in the data acquisition game, right? So they've always been good and bad actors. Is the point I want to make there.
Pretty sure there was Napster way before AI.
Napster is a fascinating precedent for everything happening now. Yeah.
And
Um,
so yeah, I mean, look, I think AI has done some phenomenal things in like drug discovery, and I know that like a lot of the folks doing COVID research at and Oak Ridge National Labs are using Blazing SQL, and so the advances in AI have definitely like done some things that have irrevocably helped society and hurt society. But it really comes down to like who the actor is, whether
yep.
they're going to use as a force of good or as a force of something else.
And as the famous quotation says, and I can never remember who said this, I need to find it. The quotation is technology is neither good nor bad, nor is it neutral, which I really like. Um, so to wrap up, I'd like to just hear a bit about the future. As AI and analytics capabilities continue to advance, what do you see as the next big frontier for data processing technologies, Josh?
Um, I mean, this isn't even self-serving. The next frontier it is around we jokingly we call it space mice. So we have the space charts and we talk about mice, modularity, interoperability, composability, extensibility, space scale, performance, and cost efficiency. Um, but is that data is getting bigger and it's being forced by AI. AI generates more data. Uh, People interact more with data, data begets more data. And so the data set size is just getting bigger. And there is this like, how do I get data faster into these systems? Now that I can ask better questions of my data, how do I analyze it better? And so speed and performance matter,
Mm,
but we have finite energy. And so another thing I'm excited about is green. I spent earlier in my life about 30 days in the Alaska wilderness backpacking around Denali, and then went
amazing.
back to the same area, 17 years later, and like I don't care where people stand on global warming or any of this other stuff. The Alaskan mountain caps, snow caps are like retreating away, and like the dog sledding is like you're like sledding on mush. And like I'm just like, I know 17 years ago it was very different than this. And you talk to the
Yeah.
locals, they're like, yeah, it was very different a decade ago. And so I do think, being energy efficient matters a lot. And so, even at Voltron Data, we recently were, our first cluster, a bunch of A100s and, some wildly impressive TCO energy consumption, 50, 70x faster, a tenth the energy consumption. And then we really looked at like some of the data and some of our design such things. And we went back to the drawing board and we're like, we could probably do this even greener. Like, really push energy consumption down and make it faster. And so, yeah, when I talked to my engineering team and I saw some of their results, I'm not going to do a spoiler alert for kind of our next quarter launch, but faster and less energy consumption.
Mm.
And I think that's where we have to go. We have to bring down the energy use for these large scale systems. And so it's not just to be like, oh, who cares? This job is, if it's 20 seconds or 1 second, the real thing we should be asking is like, how many joules did that job take?
Yep.
Like how much energy did you use to get that answer? Um, and so I think the more energy conscious we get this byproduct of performance kind of for
Mm.
free. And so I think thinking about energy consumption, data center consumption, we like to
Yeah.
joke about Coruscant. We can't be Coruscant. We can't have a city's, globe where, there's just data centers everywhere.
Absolutely.
Um,
And I love
and
the
so,
idea of displaying to end users not just cost and latent, like we always think about cost and time, cost and latency, right? And then having other forms of costs such as energy costs. I've never been to Alaska, but some years ago I went to Svalbard in the Norwegian Arctic. Amazing place actually. They have one of the seed vaults, like the apocalyptic seed vaults there, where they like put all the seeds from around the world in case something serious goes down. But seeing it was in summer, and we did see several polar bears who didn't make it back on the retreating ice pack in the middle of summer. And these dudes, they were like older polar bears who were wasting away, and the locals are like, there are more and more polar bears each year who don't make it back.
oh man.
Which is devastating. So I think these things are incredibly important. Didn't mean to bring the mood down so much, but it's definitely a call to action. But in terms of calls to action, I'd love to know what you would like to see people do. And I may be stealing yours. You mentioned Theseus briefly. I do want to say, check out Theseus. And I'm going to read the copy on the Theseus page because it can describe Theseus way better than me. But it's a distributed execution architecture that takes advantage of full system GPU hardware acceleration to enable petabyte scale analytics on data anywhere. And that's absolutely. I wonder if it's processing different data on a different day though, is it still the same engine of Theseus? Um,
Uh,
but
we joke about that a lot. Part of the reason why it's called Theseus is we wanted to be evolutionary.
yeah,
Data changes, data system needs change, and like Arrow, it's meant to be adaptable for everything from cyber to genomics. I will say, obviously, if you have large scale queries, anything over 30 terabytes, especially, reach out. There's probably not even probably there isn't a query engine that's more energy efficient and faster than Theseus. Yes, it does leverage GPUs, so you still need GPUs to run it, and they are more power hungry, but the total cost of power is reduced by
mm,
running it on GPUs and accelerators. But even without that, IBIS. We're doing really great things in the IBIS community. IBIS for local, batch, distributed, uh, real-time engines. And I believe that one way to reduce costs is to reduce rewriting code.
mm,
And so using things like IBIS, there was a customer who's like, we use IBIS to make sure that a functionality is, across all these systems, because we never want to get locked into one engine. And so if that function isn't in multiple different engines within IBIS, we won't even use that function. We'll just rewrite the code in a different way.
right.
Like, wow, that is a passion for kind of standards and like not getting locked in. And so I just can't plug IBIS more. And again, this is not data frame, Python, API versus SQL. IBIS uses both. You can
Mm,
use SQL, you can use Python. It's a lover. It's not a fighter. It's probably one of the next up and coming open standard tools that's been around for almost a decade.
yeah.
Um, so
Beautiful. So definitely check out IBIS, check out Theseus. I've linked to Voltron Data in the chat. I've also linked to Josh on Twitter, Data Matrician. Give him a follow. Lots of interesting stuff there, and check him out on LinkedIn as well. I
thank you.
I just want to thank everyone for coming. We've had, 150 people here in real time. And those watching afterwards, thank you so much for your time. Most of all, Josh, thank you not only for your time, but for your wisdom and going to the frontier of, really hardcore data processing, and bringing back all the wisdom you can. So really appreciate you, man.
Thank you for having me. This was great. And I can't wait to hear Chips in a few weeks. So, if you enjoyed this,
Absolutely.
check back in for
Yeah,
Chip
exactly.
soon.
Cool. All right. Thanks, everyone, and see you next time.
Thank you.
And scene. Dude, that went like that. I could
Yeah,
have
no,
chatted,
that was
could have chatted
awesome.
for 2 hours.